Okay, so our next topic is parallel plate capacitor. So basically, there are many capacitors in our syllabus like cylindrical capacitor, spherical capacitor, and parallel plate capacitor. So in the next few slides, we will be discussing about how to derive capacitance of a parallel plate capacitor, how to find electric field, how to find charge, how to find charge density. Okay, so basically a parallel plate capacitor looks like this. So there are two parallel plates and suppose plate area is A. These are parallel, so both the plates will have same area A, and suppose the distance between plates is D. And now we have connected this capacitor to a battery. Suppose the potential of battery is V, and if I now switch on the circuit, then see what will happen. So basically, just after you will switch on, so an electron from the negative terminal will reach this plate, and from this negative terminal of the battery, many electrons will move out and will reach to this plate. So in microseconds, basically a negative charge will be deposited on this plate, and this negative charge, there is negative charge on this plate, and this negative charge will induce positive charge on this plate. So suppose there is a charge of minus q on this plate, so it will induce a charge of plus q on this plate. So this negative will attract positive and will repel negative. So what will happen? Electron will repel and come out of this plate, and electron will get repelled and will come out of this plate and will come to the battery. So after few microseconds, the capacitor will get charged. So after getting charged, there is negative charge on this plate and positive charge on this plate, and the capacitor is said to be charged. So this is how a parallel plate capacitor gets charged. So after switching on, electron will come from negative side of the battery. It will travel to the plate of capacitor. Though the plate which is connected to the negative terminal will get negatively charged, and the opposite plate will get positively charged. If someone asks you what will be the total charge on this capacitor, so if you will see, the total charge on this capacitor will be Q plus minus Q will be equal to 0. So if someone asks what is the total charge, then it is 0. But if someone asks how much charge is stored by this capacitor, so the answer will be Q. Okay, now moving forward, now we have this plate, one plate positively charged and one plate negatively charged. So this plate is positively charged, it is connected to the positive terminal. This plate is negatively charged, it is connected to the negative terminal. So this is positive terminal, this is negative terminal. Now suppose the surface charge density of positive charge is sigma on this plate and minus sigma on this plate. Now we have already derived that due to a surface charge sigma, the electric field is sigma by 2 epsilon. Okay, so for positive the electric field will be outwards, for negative the electric field will be inwards. So for sigma, on this side the electric field will be outward in this direction, and on this side the electric field will be outward in this direction, and the magnitude of the electric field will be sigma by 2 epsilon. So now we have to find electric field in three regions: region number 1, region number 2, and region number 3. So one region is between the plates, other region is on the left hand side of the capacitor, and another region is on the right hand side of the capacitor. So now in the next slide we will see how to find electric field in all three regions. See, okay, so due to this positive charge, the electric field will be sigma by 2 epsilon and outwards. So in region 1, due to this plate, the electric field will be outwards. In region 2, due to this plate, the electric field will be outwards because it is positively charged. And at this point also, the electric field will be outwards. Okay, so due to this sigma, at this point electric field outward sigma by 2 epsilon. On this side also outward sigma by 2 epsilon. At this point also outward sigma by 2 epsilon. Now coming to this negatively charged plate. This negatively charged plate will attract electric field towards it. So at this point, electric field will be inverse sigma by 2 epsilon. At this point, electric field will be inverse sigma by 2 epsilon. At this point also, sigma by 2 epsilon inverse. Remember that the blue colored electric field are due to positive charge plate and the red colored electric fields are due to negatively charged plate. If you'll see in region number 1, one electric field is towards left, one is towards right, and both are same in magnitude, so net will be 0. Similarly, in region 3, the net will be 0, but in region 2, if you'll see, both the electric fields are parallel, like they are in same direction, and the value is also same. So net electric field between the plates will be sigma by 2 epsilon plus sigma by 2 epsilon, that is sigma by epsilon naught. So this is the net electric field between the plates of the capacitor or in region 2 of the capacitor. So if someone asks you what is the value of electric field between the plates, sigma by epsilon, to the left hand side of the capacitor 0, to the right hand side of the capacitor also 0. So electric field is there only between the plates of capacitor. Now we have to find capacitance of this parallel plate capacitor. We have already derived the formula of net electric field, that is sigma by epsilon naught. See, suppose this plate has charge Q and area A, so sigma will be Q by A. We already know that the formula for surface charge density is, so sigma is basically what? Sigma is charge divided by area. Similarly, here also charge divided by area. Now, if you will remember, then we have already derived this formula of electric field, that E is equal to minus dV by dr. There is a complete lecture on how we have reached to this formula. The lecture is relation between electric field and electric potential. Moving this dr on this side, so dV will be equal to minus E into dr. See, electric field is a constant, so dV can be written as V, E can be written as E, and dr can be replaced by D. So basically potential difference is equal to electric field into distance. The value of electric field is sigma by epsilon naught into D. Sigma is charge by area, so V comes out to be QD upon A epsilon, but Q is equal to CV. We have already covered this in our last lecture, that Q is equal to CV. Putting this value of Q in this formula, so V and V will cancel out and the formula of capacitance will come out to be epsilon naught A by D. So capacitance of a parallel plate capacitor directly depends on area, that we have already discussed, because more the area, the capacitor will store more charge, and inversely proportional to D. So capacitance is basically epsilon naught A divided by D. You have to remember this formula by heart because there are many questions related to this formula in MCQs also, in theory also. This derivation on this slide is very important. Now I'll discuss one numerical related to this formula, and then you have to submit one online quiz after learning from this video. Suppose a parallel plate capacitor where plate area is 2 meters square, distance between plate is 1 meter, potential of battery is 40 volt. Find capacitance, surface charge density, electric field and charge. C is epsilon naught A by D. We have epsilon naught, we have A, we have D. This epsilon naught will be given in the question. You don't have to remember it, but after learning for 6-7 months, you will automatically learn the value of this epsilon naught. So we have C now. Q is equal to CV. Putting value of C, putting value of V, the answer comes out to be 80 epsilon naught coulomb. Because C is epsilon naught A by D, A is 2, D is 1, so it is 2 epsilon naught farad. Q comes out to be 80 epsilon naught coulomb. V is equal to E into D, so E will be V by D. V is 40 volt, T is 1, so answer is 40 Newton per coulomb. And finally sigma is charge divided by area. Charge is 80 epsilon naught, area is 2, so sigma comes out to be 40 epsilon naught coulomb by meter square. You have to put the unit. The units are mandatory in this kind of questions because they contain a weightage for every unit. There's a weightage of around 0.25 or 0.5 mark. Okay, so now you have to submit the quiz, and if you have any doubt at any point in this slide, you can send me. Okay, bye bye.